Good morning to everyone. Myself is Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. I am going to teach the subject data structures using C++. Today we are going to discuss about the topic List ADT. List is a linear data structure which is basically the collection of elements arranged in sequential manner. We can implement the list in two ways, array implementation as well as linked list implementation. In the case of array implementation, we can store the element in sequential order. The list is implemented with the help of the array. The other way is can use pointer or linked list as an association for sequential. This is known as linked list implementation. List is an ordered set of elements. The general form of the list is A0, A1, A2 up to AN-1, where A0 is the first element and A-1 is the last element of the list, where N is the size of the list. Suppose A is the element which is present in the position I, then AI plus 1 is the successor and AI minus 1 is the predecessor. Various operations performed in linked list are insertion, deletion, find, and we can also display the element present in the list. Insertion in the sense we can insert the element at a particular position. Deletion in the sense we can remove the data that is present in the list. Find in the sense we can search for a particular element in a position. And print in the sense we can display the element that is present in the list. As I told that the list can be implemented in two ways, array implementation and linked list implementation. Implementation of array is similar to that of the array implementation. So we will see the list implementation using linked list. We can see the linked list implementation first. List consists of a series of nodes. Each node contains the elements and the pointer to its successor node. The linked list consists of two parts. The first part is the data part and the second part is the address part. The linked list consists of two fields. First part is data field and the next part is the address field. The data field is nothing but the data part is otherwise known as element or item, whereas the address part is otherwise known as reference or the next pointer. The address bus contains the address of the next node. The pointer of the last node will be always null. See the single linked list. A single linked list is a linked list in which each node contains only one field pointing to the next node in the list. There will be a header node or a header. It contains the address of the first node, whereas the last node will not contain any address. It will be simply null. In each and every other node will contains the address of the next node. So each and every node contains two parts, the data part and the address part, whereas the data contains the data or element or item, whereas the address part contains the address of the next node. Consider an example. The first node that contains the data part as 10, second node 20, 30, 40, whereas 40 is the last node which does not contain any of the next node, so it is null. That example, consider that 1000 is the first node. It contains the data. Query address 720 contains the data A3 and the next pointer contains the address of 992 which points to the address 992. The 992 contains the element data as A4 and the address part of 992 contains the next address as a 692, whereas 692 contains the data part as A5 and it does not contain any next address, so it is treated as null. Where A5 is the last node, 692 is the last node, it does not contain any address of next node. Declaration is the class node. It contains two things, that is the data and the address part. Next is nothing but it is a pointer variable which contains the address of the next element. Various operations that can be performed in linked list is insertion and deletion, and we can traversal the element present in the list, which for a particular element. In case of insertion, overflow is a condition that occurs when no free memory cell is present in the system. When this condition occurs, the program must give an appropriate message. Insertion at the beginning of the linked list. To insert a node at the beginning of the single linked list, you need to follow these steps. Create a new node with the given data. Set the next pointer on the new pointer to the points to the current head of the list. And next one is update the head of the list to point to the next node. So consider an example that we are going to set a new node in the beginning of the list. Already the list consists of 3 elements, 20, 30 and 40. The new node is new node contains the data part as 10. Note that the head contains the address of the first element, so we have to set the address of this new node with the address of this so we have to set the address of the new node with the address of the first node in the linked list, that is the new node next pointer address should have the address of first node's address. After storing the address of the list first node address to the new node address, we have to change the header to the new node address. The new node will be linked with that of the list of collections of the node which is already present in the list. In case of insertion, first you have to create a new node with the help of the new keyword new. After creating the new node, we have to set the data part with the item, then the next pointer should be set with null. We have to check whether the node which we have created, the new node is the first node in your linked list. For that we are checking whether the head is equal to null. If the head is equal to null, this is the first node, so we have to check if the new node is the first node in the list, then set the address of the new node to the head. The head contains the address of the first node in the list. Otherwise, assign address of the head node to the temp and set the address of the temp to assigning the address of the first node in the list to the temp. Set the temp address next address to the new node, which is the first node in the list. Note that the head contains the address of the first node in the list. In order to search the element present in the node, start from the first node and compare the start part with the element to be searched. If it is present, then the corresponding position is returned as target 20. In order to search the element, we have to set the first node's address to the temp. For that, we have to check whether the first address is not equal to null. If the address that is not equal to null, we have to check the data part with the element we have to search with the key. So if it is present in that, we have to print that the element is found. Otherwise, we have to move to the next node, that is by setting temp equal to temps next. And by incrementing the position, we have to check proceed with the same procedure again and again until the element is found. In order to delete the element, to delete a node from the beginning of the single list, we have to perform the following steps. If the list is empty, we cannot perform any deletion. Update the head of the list to point to the next node. So consider this example. The example consists of 4 nodes. The first one node contains the data 3, second node contains the data 12, third node contains the data 15, and the last node it contains 18. Data part is 18. So we are going to delete the first element present in the list. So by setting the headers value to the address of the second node, automatically by default the first node will be treated as deleted. So set the temporary pointer with the address of the first node and check whether the address of the first node is equal to null. If it is equal to null, then the list is empty. We cannot perform any deletion. If the list is not empty, then we have to check the data whether the data is equivalent to that of the element we are going to delete. If it is equal, then head equal to heads next. Delete the temporary node. Then this is the first case, we are going to delete the data that is present in the first node, or otherwise we have to repeat the step until the particular node is reached by temp equal to temps next, and until the particular data is reached, we have to perform the operation again and again. At last, if temp is not equal to null, the particular data we want to delete is not found in the list, so we cannot delete that particular element. Otherwise, we have to perform the next operation, previous next equal to temps next, until the particular it is deleted. This is all about the operations performed in the linked list, and this is about the single linked list. We will see the next concept in the next class. Thank you.